It's always bad news when you come back to check your power logger after you think you've been recording data for a week or two. You find out you've recorded absolutely nothing. You look around, the power cord has come unplugged. You take a look, maybe you have loose test leads, a voltage lead has come loose, something's been hooked backwards, a current clamp has come loose. Well, these things happen, but do what the pros do. Always use a good connection checklist to make sure that you set your meter up properly each and every time.
Well, the truth is, everybody makes these kinds of mistakes at least once. Hi, I'm Randy Barnett for Fluke. With 35 years of experience as an electrician, I've become a power quality expert and electrical trainer. In this video, we're going to run through a checklist that the pros use to make sure that they connect their power logger properly and avoid common connection errors.
So here are 3 important checklist items for you to always remember. First, check the connections. Second, you're going to check the numbers. And third, check the arrows, as we say. There are 4 common errors when it comes to connecting power quality analyzers. First, incorrect clamp directional orientation, probes on the wrong phase, missing voltage, incorrect phase rotation. Let's take a look at each one of these, see how we can detect the problem, and then what to do to fix it. Incorrect clamp directional orientation. After you've determined what equipment you need to monitor and gathered the appropriate PPE and put it on and set up your barriers, make sure that you have all of your analyzer equipment set up and ready to go. And remember, if you're a qualified person, you can go ahead and override those safety interlocks to open up that cabinet door. Just remember, safety first. Always stand to the side when opening up those doors. Then check your analyzer equipment. Make sure that all of your test leads are correctly labeled and color-coded. Look at your arrows on your test leads. Make sure that on the current probes they always point towards the load. Match proper phases. Phase A test lead to Phase A, Phase B test lead to Phase B, and so on. This is best accomplished if you use color coding on your test leads to match up to the color coding on the equipment. With your voltage test leads, make sure you first get a good grounding connection in your equipment. Then connect voltage Phase A test lead to Phase A, voltage test lead B to Phase B, and voltage test lead C to Phase C. Now it's time to put that checklist to good use. An easy way to do this, to check your connections, is to first go to the Phasor diagram on your analyzer. Phase A voltage is very much out of phase with the Phase A current. Must be a connection problem. Well, sure enough, if we go back and we take a look at the equipment, we find out that we have the arrow pointing in the wrong direction for Phase A. So, carefully, we go ahead and reverse that current clamp and make sure now that the arrow is pointing towards the load. That should give us proper voltage and current relationships back on the Phasor diagram, which we can recheck. Now when we go back to the Phasor diagram, sure enough, we find some displacement between Phase A voltage and the Phase A current. However, we notice that the Phasor arrow is in the wrong direction. The Phasor arrow should be pointing in a counterclockwise direction, but it's showing a clockwise direction. Probes on the wrong phase. If you have a Phasor rotation problem, take a look at your connections. Go back to the current clamp and the voltage leads and make sure that their color coding matches up. If they are mismatched, then go ahead and swap the leads as necessary to correct the problem. Then always go back to your power quality analyzer, to the Phasor diagram, and make sure that for A, B, C rotation, the arrow is pointing in a counterclockwise direction on the Phasor diagram. Missing voltage. Another common problem is to have one of those voltage leads pop off long after you've left the equipment. You'll see this indicated on the Power Quality Analyzer. If you look at the scope screen, you'll notice that one of the phases is missing. The same is true if you go to the Phasor diagram. To correct this problem, obviously you have to go back into the equipment and securely fasten that voltage lead. Then, of course, go back to your Power Quality Analyzer, make sure that you have all three phases present, then over to the Phasor diagram, and make sure that your Phasor diagram is correct. Incorrect phase rotation. So, for normal phase A, B, C rotation, on the Phasor diagram, the arrow points in a counterclockwise direction. At the 0 reference point, the thick black line indicates the phase A voltage. Phase A current, the thin black line, can be seen lagging behind the phase A voltage. Phase B voltage is the thick red line at the 120 degree point. The phase B current is the thin red line lagging behind phase B voltage. Phase C voltage is the thick blue line at the 240 degree point. Phase C current is the thin blue line lagging behind phase C voltage. You can also go to the scope and notice correct phase rotation. You see phase A, the black phase, build up, then it's followed by phase B, the red phase, and then phase C, the blue phase. Now, one last item you should be aware of on that Phasor diagram screen is that you can actually select phase sequence. To do that, you go to the Function Preferences menu, select Scope and Phasor Preference, and it gives you the option as to whether you want to look at phasor rotation or indicate phase sequence on that screen. Should you choose phase sequence, notice now on your phase sequence diagram the arrow points in a clockwise direction, indicating you're moving from phase A to phase B to phase C for normal rotation.
So, the bottom line is, use a checklist and avoid those embarrassing moments. I'm Randy Barnett for Fluke.